So our critical number is x equals 1. Which means that we just need to see negative infinity to 1. Whoops, sorry, that's not the way this book teaches it. Let me get rid of the interval and do a line. So we need a test point at x equals 0 and x equals 2. So let's see, my derivative is negative when x equals 0, and when x equals 2, it's still negative. So that means decreasing and decreasing. That doesn't feel right. Because doesn't it do this? Oh, that is decreasing and decreasing. Oops. So, is there more to answer on that one?
Well, I think you just sketch the behaviors and do that thing. I didn't do that thing.
You didn't do this thing?
That's the thing you didn't do.
Oh. Yeah, don't forget your critical numbers are where your function is undefined. Or I think it's where the second derivative, where the first derivative is undefined also. Remember that. I don't know, the brain is gone. It's what happens when you get old. Just wait till next year, because then I'll be really old. Yeah, I'm not doing 85 for you. Word problems take way too long. So, how many people struggled with 85? Whoa. Okay, so that means I will not collect your homework today, and I will post a solution to number 85. And while I'm at it, I'll just do 75 also so that we can move on. So yesterday we were talking about the second derivative test and realized that most of the time we don't even need the first derivative test anymore. Only a couple of times do we need the first derivative test. And we were like halfway through second derivative test and kind of got stopped for time. One of the things I talked to you about was the third derivative test. I read about it a little bit more. There isn't really a third derivative test. There's a higher order derivative test. So that's what it is. So what you do is you take the derivative, take the derivative, take the derivative, take the derivative until you get to the point where when you plug the critical number in, the output value is not 0. Once you get there, then what you do is you look at how many times you had to take the derivative. Yeah. Well, let's see, if the number of times you took the derivative is odd, there's no maximum or minimum at C. In other words, it's an inflection point. If the number of times you took a derivative is even, then if the derivative is less than 0, it's a maximum. And if the derivative is greater than 0, it's a minimum. So now I can see, now that I've actually researched this, why we don't use the higher order derivative test. Because it's kind of complicated. I mean, you could be taking derivatives forever. to get down to the one where finally I plug that critical number in and I finally end up with something that's not 0. If it's, yeah, so there it is. If you're interested in it, I did just explain it to you, and you can use the higher order derivative test. But what we're gonna stick with is we're gonna stick with, if the second derivative test doesn't work, we're going to pop back to the first derivative test. Oh, fun. Forgot to do this. Take a number and pass it around. And don't be picking through it and pick numbers that are the same as your buddies. Just take a number out. Okay, so here's a polynomial function. We'll do that one because they're easier to take their derivative.
Are you taking the second derivative?
Pardon?
Are you taking the second derivative of that?
We're going to do the second derivative test on this.
Because yesterday's very different.
I know, that's what I said. Let's do a different one. Because that one I didn't finish up, but I got halfway through the second derivative test. We're going to do this one and go all the way through the second derivative test. So it'll give you a little more experience. So whenever we are using the second derivative test to help us sketch a function, I guess that means we better find the second derivative. To find the second derivative, you have to find the first derivative, I think. Don't you?
Yes.
I don't know how to find a second derivative without finding the first. And so the second derivative is negative 20x cubed plus 12x. Critical numbers. Oh, I guess we better go back to find the critical numbers there. That's the confusing part, I think, of the second derivative test, is you have to go back to the first derivative to find the critical numbers. And if you forget to do that, then you're kind of lost on what to do. What do I do once I've taken the second derivative? So let's look at this guy and see what we can come up with. Where is it equal to 0? Because that's how we find our critical numbers. Well, I can factor an x squared out. Well, that's not going to be pretty answers, is it? So I can say x squared equals 0, or negative 5x squared plus 6 equals 0. This one's easy enough. Take square root of both sides, and you have x equals 0. Remember the square root principle? Isolate the x squared. And we have that x equals plus or minus the square root of 6/5. Which would probably be a good idea to have an approximate value for. Let's go with that. 'Cause we'll keep the real value, but an approximate value will help us on the number line if we need a number line. So now what do? Oh yeah, now we plug the critical numbers into the second derivative. So critical numbers into second derivative. So let's start with the smallest one. Negative 6/5, the square root of negative 6/5. Oh God. What happens when you make one up? You make up weird, icky numbers. Negative 20 times square root of Oops, I forgot to put the negatives in there. Because I forgot to put the negatives there. Oh, no, that's the negative there, I just didn't see it. Ah. I gotta put the numbers in there. Second, insert negative 13.14.
Negative?
Hmm?
I got negative 13.14.
Did you?
Yeah.
I got negative 13.14.
Did you have a negative here and a negative here?
No.
I think I had a negative 20.
Yeah, negative 20 times negative square root of 6/5 cubed.
Oh, that's a negative.
Oh, I see what I did wrong. I needed parentheses there. I still got a positive. What the heck?
I didn't use the negative. I didn't use negative root value. Try that.
Now I get 40.7. Somebody else plug it in. This is a positive number, so it's going to be 20 times about 1. Should be a negative number, shouldn't it? Oh, that's just to the first power.
The first one, the 20 times the cube is negative 26. And
And then that one's going to be negative, so it will be negative. Criminy biminy. Let's see, when we plug f of 0 in, we get 0. So the second derivative is 0, which we'll come to something in some conclusion in a moment. And f double prime of positive square root 6/5 is what?
Positive was a negative 13.14, and then when you use the negative value, it becomes positive 13.7. Just depending on the sign, it changes the.
You guys are confusing me. Is this number negative or positive?
No.
That one's a negative.
Is this number negative or positive? Yeah, because that'll be a positive. Yeah, okay, so we're good. Okay, so second derivative test says if the second derivative is negative, we have an unhappy face, which means we have a max. Second derivative is positive, means we have a happy face, so we have a min. When the second derivative is 0, we don't know what to do. Oh, that's fine. So when we have where the second derivative test gives us a 0, then what we do is we go back and we use the first derivative test. Or you can use that higher order derivative test, which would take some time to, well, 2 more derivatives would get you down to a non-zero, I think. No, it wouldn't be 4 more derivatives. Wait, 1 more derivative would do it. Oh well, never mind, let's go back to the first derivative test. So the first derivative test says, let's check on either side of that number to see what's happening with the function in the first derivative. And we have to be careful that we don't go too far over there. We have to be sure that we're within this range. So the other critical numbers, we know that one's a max and one's a min.